Okay guys, today what we're going to be doing is taking polynomials. They're not going to be just to the second power, they're going to be higher power. So you'll see some thirds, second, even some fifths. You need to factor it down as much as it can go. Now, it's similar to how you do the second power quadratics, like GCF and T, but at the end, you always need to keep factoring down your dots as far as it'll go. So here we have a trinomial and three terms. Now before you did your GCFT and that was it, but this is going to be different. You're going to have your GCF, you're going to have your T step, and the T will work, I guarantee it, okay? A equals 1, we still want to pay attention to that. But then at the end you need to always check and see if you have any dots, because you might, because they're higher powers. So that's kind of your three steps. Okay, so the GCF, do I have a negative in front? I don't. Do I have X on everything? By the way, that needs to be to the second power. Okay, just put a second power there. Okay, do you have X on everything? No, you don't. And then you got 1, 5, and 36. So basically, you know there's not a GCF. Okay, so I go A, B, C, and I take 1 times negative 36. So that's going to be negative 36, searching for a difference of 5. So far, no difference, okay? Or no, it's the same thing. Okay, 1 and 36, no. 218, no. 312, no. 4 and 9, bingo, okay? Now is A equal to 1? It sure is. So I'm going to write yes. So that tells me I just need 2 parentheses. Now here's where the game changes. Okay, here's where the game changes. It's x to the fourth, not x to the second. So x to the fourth needs to become, we need to split that in half. So it's x second and x second, because that's what x to the fourth is. X to the second times x to the second. Now we have minus 5, so, and by the way, we put 4 and 9. So we have minus 5, okay? So I have minus 9, and difference would be plus 4. Okay, now I'm not done, because x squared plus 4, that's done. That's not a dots, it doesn't have a minus. Even though that's x times x and 2 times 2, the plus means it's prime, so we circle that. Okay? And then the difference, we have a minus x times x, 3 times 3. So that is x plus 3 and x minus plus 3 and x put plus and minus, x minus 3. Okay, now do you have any more dots? Okay, now you know that's prime, so circle it because it's a plus, and that's a minus, but x and 3 are not perfect squares. Okay, so that's done. So what are all the factors I circled? Okay, I didn't have a GCF. I've got x squared plus 4 times, and then I've got x plus 3 times x minus 3. Okay, and that's the factorization for it. Okay, next problem. This is 2, so we got the GCF, and then adopts, okay, and then after I'm done with that, there might be another dops, okay? We have to keep doing dops till we can't do dops no more, okay? So GCF, well, we have a negative in front. We have x on everything, and then 2 and 32, you can divide those both by 2, so that's negative 2x. So I pull out negative 2x and circle that, so then I go divide by negative 2x, and that's going to be 1x to the fourth, or just x to the fourth. If it's a 1, I'm just going to put x, minus 16, and the x's there cancel. Okay, now do you have a dots? You have a minus and x to the fourth. Well, if you have an even power, it is, because it's x to the second times x to the second. And then 16 is 4 times 4. So x to the second plus x to the second, and then 4 and 4. Now let's look at this. The one with the plus is prime. I guarantee you that. If you have a binomial with a plus, it's prime. Now as this adopts with the minus, x times x, 2 times 2, so x plus 2, x minus 2, and then that's prime. Is that adopts? No. So that's prime. So what are my factors? My GCF, you need to write that down. Your x squared plus 4, and then your x plus 2 times your x minus 2. So there I broke it up as far as I could. Okay, next problem. If the camera dies, we'll go to video number 2. Okay, so again, 3 terms. So we're going to go GCF, and then the t with a equals 1. Now, since my power is higher than a 2, I'm going to need to see if I have dops at the end, okay? So, GCF, you don't have a negative, but you have x on everything. And then 6, 13, and 5, I can't really do anything with, so x is coming out. Then we're going to divide those all by x. Okay, so it's going to be 6x to the second plus 13x minus 5. So ABC, 6 times negative 5 is negative 30, difference of 13. So I don't, 2 and 15, yep, there it is. A is not equal to 1. No, A equals 6, so you need 4 parentheses. So when I do 4, I'm going to lead off each parentheses with the A, the 6. Then I split x to the second power into x times x. If it's if it would have been a fourth power, I would have went second and second. And then 2 and 15. So I have plus 13x, so I know I've got plus 15. Okay? And then difference means they're opposites. So that's going to become 3x minus 1. And we divide that by 3, that's going to be 2x plus 5. Okay, and by the way, this x here, I need to write that in my answer. Okay, this has a plus, so you know it's prime. This has a minus, but that's not adopts, okay? So, I can forget this. So I've got x, I've got 3x minus 1 times 2x plus 5. Okay, next problem, another 3-termer. Okay, so GCF and the t, just like before, just like the ones with second powers, but there might be adopts over here. There might be. I'm going to need to check for it. Okay. Okay, so GCF, do you have 1 on every, do you have a negative? No. Do you have x on everything? No. And then 1's your smallest, so there would not be a GCF for me to pull out. So 1 times negative 12 is negative 12, difference of 4. 1, 12, no. 2 and 6, there you go. Now is A a 1? Yes. So I don't need to lead off with a number, but it's x to the 4th, so I go x second and x second, and then 2 and 6. So I have plus 4, so we're going to have plus 6 for sure, and difference means minus 2. Now the one with the plus is prime. The one with the minus, you got, yeah, that's x times x, but guys, 2 is not a perfect square. No, it's not 1 times 1. That's 1, okay? Not a dops, okay? So I'm done. Don't need that. So I did not have a GCF. I've got x to the second minus 2 times x to the second plus 6. And all you're doing is factoring it, breaking it down. Okay, next, 2 terms. So we're going to go with the GCF and then right to dops. But after I'm done with that dops, there might be the possibility of another dops anytime I got powers that are higher than 2. Okay, so GCF, we have a negative in front. 2 and 50, we can do, can't do x, but you can do 2. So negative 2 pulls out, circle that. Okay, so that's going to be x to the 4th. If it's a 1, I'm going to start putting just x, minus 25. Now, is that a dops? You have a minus, and then 5 times 5, and then x second times x second. Okay, so that's x second plus 5, x second minus 5. Okay, so dots, well, the one that's plus is prime. Circle it. Prime means it's dead. The minus, you have x times x, but 5 you can't do, so that's also prime. You don't need that. So I've got negative 2 times x squared plus 5 times x squared minus 5. Okay, next problem, 3 terms. GCF, and then the t-chart. Okay, a equals 1. We always got to be watching for that, same as before. GCF, I have a negative in front. No. Do I have x on everything? Sure I do. So x, okay, 1, 5, and 4, I don't think you can do much with those. So x, and then you go divide all these by x. So that's going to be 1x to the 4th minus 5x to the 2nd plus just 4. Okay. All right, A, B, C. So 1 times 4 is positive 4. So sum of 5. 1 and 4, I think 1 plus 4 is 5. So is A 1? You bet. Okay, so yes, it is. But I don't need to lead off with a coefficient, but I do have x to the 4th. So I got to go x second and x second. 1, 4. So I have minus 5. That's my B, so I have to have a minus 4. Sum means they're the same, so minus 1. Okay, and then we have to see if we have any more dots. Well, that's a minus. That's 1 times 1, and that'd be x times x. But so is that one too. X times x and 2 times 2. So since they both are, I need 4 of them. Here I'm going to go x plus 1, x minus 1, and then x plus 2, and x minus 2. Okay, the ones that are plus are prime, and those minuses you can't do anything with because that's, if it's just x, it can't be a perfect square. Okay, all those are prime. So I had x as my GCF. I didn't circle these because neither one of those was prime. And then I've got x plus 1 times x minus 1 times x plus 2 times x minus 2. Okay, next problem. 2 more left. 3 terms. So 3 terms, so I'm going to look for the GCF. Then I'm going to go to my t table. And then since the exponent's higher than 3, there's a possibility of a DOPS. Difference of perfect squares. Okay, so GCF. This one's kind of weird. You don't have a negative, but you have x on everything. Not only do you have x on everything, you have at least an x to the 3rd on everything. So you got to go x to the 3rd. Okay? X to the 3rd, and 3, 18, and 24, you can also divide those by 3. Okay? So 3. So I divide all these by 3x to the 3rd power. Okay, so it's going to be 1x to the 2nd minus 6x plus 8. A, B, C. 1 times 8 is 8, positive, so sum of 6. Nope, bingo. Okay, is A 1? Sure it is. 2 parentheses. Now, I don't need to lead off with anything because A is just a 1. X second will become x times x, and then 2 and 4. So I have minus 6, so I'm going to have minus 4 for sure. Sum would mean they're the same. Now, are either one of those dots? You have minus here, but x is not a perfect square, so that makes that prime. Circle it. Okay. X minus 4. That's not perfect squares, so that's also prime. So I'm not going to do anything there. Okay, so I have the 3x to the 3rd times the x minus 2 times x minus 4. Okay, last one. 2 terms, so GCF. and dots. And there might be another dots, who knows? Okay, so GCF. Okay, I can't divide, no negative, 1 and x, we have x on everything, at least x. So x, 1 and 9, you can't do anything with 1 and 9, so x comes out. So it's going to be 1x to the fourth, or x to the fourth, minus 9. Okay, now do we have a dots? Well, we got minus 3 times 3, and we can split that in half, x squared times x squared. So x squared plus 3 and x squared minus 3. Now that's, circle that, x squared plus 3, that's prime with the plus. And then minus x times x, but I don't think I can do 3. So circle that because that's prime. So I can't do that. So I have x times x squared plus 3 times x squared minus 3.